Hello guys, today we'll try to learn about operators in Python. So what are operators? Operators are nothing but symbols which perform some processing of data. It performs some data processing. So there are many types of operators in Python like I have shown here. And they are arithmetic operators, comparison operators, assignment operators, bitwise operators, logical operators, membership operators, and identify operators. First of all, we'll try to learn arithmetic operators. So what are arithmetic operators? Arithmetic operators are used to perform arithmetic operations like addition, subtraction, multiplication, division, modulus, exponent. So let's dig into interpreter and try to perform some examples. Let's open the interpreter. Right. Python. All right. So we are into interpreter now. So instead of this Python interpreter, let's enter into interactive Python interpreter. So interactive Python interpreter and interpreter are same, but interactive interpreter is nothing but a normal Python interpreter with steroids on it. It has various new functionalities and attributes, etc. stuff to use for our convenience. So let's enter into interactive Python interpreter. Basically, for normal interpreter, we'll type just Python. But in case of interactive interpreter, we'll need to use I before Python what. So this is not nothing but interactive session. All right. So we are into Python interpreter now. Let's know about arithmetic operators. Try to declare two values with some by assigning some other values to it. Try to declare two variables by assigning some values to it. A is equal to 9, B equal to 8. Let's perform addition on it. Speed. So that's it in Python to perform addition. And in 2.7 we are using just the word print in order to print the value of a variables. But in case of Python 2. Python 3, we need to use this print statement as a function. Print has been converted into function in Python 2.3, like print of a plus b, print of a plus b, c. So you can able to print the value of a variable in two ways, by using print as a statement and print as a function. All right. So let's also know, let's perform some subtraction. Sorry, minus b. That's it. 9 minus s is equal to 1. And also multiplication. Let's take some other values by creating some different variables. In Python, we can perform multiplication by using an operator star. So this was output. Now let's get to this division. One. So when we divided the dividend a by b, 4 by 3, we'll get the value as 1. And the next one was modulus. So what is meant by modulus? Modulus is nothing but the remainder of the division operation. For example, a is equal to 45, b is equal to 6, and when you type a modulus b, so the output should be 3. So how we got the output as 3? When we divided 45 by 6, the actual the quotient was 6 sevens 42 and the remainder was 3, so that was the actual output. If you don't understand that, I'll show you. 6 45. So in division of general mathematics, if you divided 45 by 6, the value should be 7. 6 sevens 42, and the remainder should be 3. So this was the actual modulus. Now exponent. So what is meant by exponent? Exponent is nothing but x to the power of 5. Okay, let's also try to give an example for this. Let's take a is equal to 4 and b is equal to 3. I'm sorry for that. A is equal to 4, b is equal to 3. So how you will implement the exponent functionality in Python? Simple. A double star b. Why we declare b is equal to 4? B must be 3. Okay, whatever. 4 to the power of 4 is nothing but 256. So this is equal to 4 into 4 into 4 into 4. So this was the actual processing behind the exponent functionality. Let's enter into comparison operators. So what are comparison operators? Comparison operators are used to compare the values on both sides of it. They are also called as relational operators. So some of the the comparison operators are greater than, less than, greater than or equal to, less than or equal to, not equal to, and not equal to can also be written as another can also be written with another symbol, not equal to. Let's see an examples for this. A is equal to 9, b is equal to 8. Let's initially first check greater than. Whether a is greater than b. True, of course 9 is greater than 8. And also check less than. A is less than b. False, of course. A is greater than b, and 8 is less than 9, and hence it is false. Now let's check greater than or equal to. A is greater than or equal to b. I'm sorry, we shouldn't give any space between those operators. Yes. Less than or equal to b. Of course it is false. And what was the remaining on it? Equal to. Whether 9 is equal to 8, was that true? Let's check it out. So please observe here. If we use single equal to, then it indicates that we are assigning a value to a variable a. But if we use double equal to, it means that we are checking the value of both variables here. Okay. So and next, not equal to. A is not equal to b. Was that true? Of course it is true. 9 is not equal to 8. And the not equal to has two symbols. This one and another one. Let's also check with that. Yes, of course it's true. So what are assignment operators actually? Assignment operators are used to assign values to variables. And the different types of assignment values are is equal, plus equal, minus equal, and so on until the exponent which I have seen in the past. Okay. Okay, let's try this with examples. A equal to 5. So we have assigned a variable, we have assigned a value of 5 to a variable a. I mean, we are creating variable over here and assign a value to it. So this is all about assign value. Now let's check what is meant by plus equal to. It's nothing but it adds the right side value to the left side value and assign the result value to the left side value. Okay, let's see an example. A plus equal to 2. So the result should be 7. Let's print A. So how Python has calculated that? A plus equal to 2 is indirectly equals to A equal to A plus 2. So this was so this statement was actually equal to A is equal to A plus 2. But in short terms, Python we can able to notify Python in this manner. Let's check that. A is equal to 7. A is equal to A plus 2. A plus 2. Print A. So this was the output. So this is all about plus equal to, and similarly with minus equal to. If A is equal to 4, A minus equal to 1. So this is equal to A is equal to A minus 1. Since A is equal to 4, A is equal to 4 minus 1, which is nothing but 3. Print A. That's all. And that's all with the multiplication, and that's all with the division. Okay, if you want example, let's take another example then. Is equal to 4. A division equal to 2. The answer should be 2, which is nothing but 4 by 2, which is nothing but A by 2. Print A. Okay. Next, B is equal to 3. Equal to 2. So here 3 into 2 is equal to 6. Print B. Okay. And now the modulus. As we have discussed just now, the modulus is nothing but the remainder of the division operation. Okay. Let's initialize another variable called C. C is equal to 11. C modulus equal to 2. The answer should be 10. I mean, if we divide 11 by 2, the remainder was 1 actually. Okay. Print C. So the remainder should be 1. Okay. Now the last one was exponential. Let's initialize another variable is equal to 3, and let's try to check 3 to the power of 4, which is nothing but 81 equal to 4. Print D. Yes, that's right. Okay, now we have got to know about assignment operators, and let's dig into bitwise operators. So what are bitwise operators? Bitwise operators compares values in binary formats. These operators work on integers. When performing bitwise operators on integers, initially these integers are converted into binary form, and then they'll use some comparison. All right, so let's dig into it with some example. And the bitwise operators are, and this symbol was called as binary AND, binary OR, and binary XOR, and binary complement. This is nothing but the negation, and binary left shift and binary right shift. Let's get to know first about this binary AND. Let's try to create two variables over here. A is equal to 19, B is equal to 18. So we initialized, or we created two variables with values 19 and 18, let's perform a bitwise AND operators on these two variables A and B. So the output was 18. How? So in the background, Python first converts this 19 and 18 into binary format and then performs the AND operation. Let's check what is the binary format of 19 first. How you can able to check that in Python? Simple. We have some function. So the binary format of A, which is nothing but 19, is 10011. Let's also know the binary format of B. Know the binary format of B. Okay. Python compares these two binary formats over here and finds the resultant binary format, and then it converts that binary format into integer. Okay, so how it compares, actually how it performs AND operation with these binary formats. Okay, in case of AND, the resultant value will be 1 if both values are 1. Okay, let's try to understand this with an example. Let's copy this. So how Python performs the AND operation. The resultant value of 1 and 0, I mean the resultant comparison of two digits will be 1 if both digits are 1 in case of AND operation. For example, here 1 and 0 should be 0. Will come from start. 1 and 1 is 1 and 0 and 0 is 0. 0, 1 and 0. Sorry, it was 1 actually. So the resultant value should be 1 only if both comparison values are 1. Otherwise the value should be 0. For example, the both values over here, the both comparison values here are 1, and hence the resultant value was 1 in case of AND. Similarly with 1 and 1 is 1 and 1 and 0, since both are not ones and one value is 1 and one digit is 0, the resultant value should be 0. So initially Python got the result by comparing two binary formats of two integers as this one. So let's try to find out what was integer notation of these binary formats. So you can able to find the integer format of a binary digits by using a function called bin in Python. Bin of this one. Sorry, it's not bin actually. Bin is used to convert the integers into binary formats. If you want to convert the binary format to integers, so you need to use a function called integer, int. Alright, so this is a value of 18 actually. Alright, so this is a value of 18 actually. This is similar with OR operation. In case of OR operation, of course, we got to know about AND operation, and now let's know about this OR operation. So how Python compares two binary formats, two numbers actually. So for 19 and 18, these two are the binary formats, and Python initially compares the binary formats, and the resultant will be a binary, and this binary will be converted into integer. So now we got to know about AND, and let's know about OR. In case of binary OR, the resultant, the result will be 1 if at least one of the bit is 1. For example, previously the result will be 1 only if both values are 1, but in the case of OR, the resultant will be the result will be 1 if at least one of these comparison values was 1. Okay, and now the output will be 1. Since at least one of the above two values is 1, the value will be 1. 0, since no value is 1, 1, and at least since at least one of the two comparison values is 1, the value will be 1. So this is the value of OR, and now Python converts this binary format to integer. So let's check what was the value of A and R. Sorry. So the value should be 19 over here. All right. So this was all about binary OR. And what was about this binary XOR? Binary XOR. Okay. XOR. In case of binary XOR, the result will be 1 if at least one bit is 1, but not both will be 1. I mean, uh, when comparing these two values, at least one of the value should be 1. If both the value should be 1, the value should be 0 and the result should be 0. So this is a condition in XOR. Okay, let's deal with it. Since at least, I mean, if both should be 1, the value should be 0. 0 0 0. If both are 1, the value should be 0. If at least one value should be 1, I mean, if at least one value is 1, the resultant value should be 1. So this is a binary format when Python compares two integers 19 and 18. So what is integer representation of this? A, B is 1. Okay. Let's check bin of 1. Okay, so the binary format of 1 was this one. So now we got to know about binary OR. Similarly with binary complement, in case of binary complement, when you okay, let's initialize another variable. A is equal to 9. So how you negate a value? It's nothing but A. So the negation of 9 is nothing but A, and you can also convert this minus 10 to 9 by using another negation, like minus 10 negation back to 9. So this is all about Python complement or Python negation. So what is a left shift? Now we'll learn about left shift. Left shift is nothing but the left value is moved by number of bits left, I mean specified by right value. I mean the left value is moved left by the number of bits specified by right value. For example, let's take A is equal to 100. So what is a binary format of A? It's nothing but 1100 and 100. When we apply left shift operators, I mean left shift operation on this variable A, let's check what was the result of this. Left shift 2. So what is a binary for? So the resultant integer was 400. Let's check the binary format of this 400. So you can able to see that now 1100 100 1100 100. So the value, the binary format has moved 2 digits left, 2 digits left by adding 2 digits right. So it has moved left actually. Now let's check about right shift. Let's initialize another variable. All right, let's apply a right shift operation on this variable. Two. Was that really 25? Okay, let's check it. So initially we need to check what was the binary representation of B. B. Okay, so the binary representation of B was 1100 100. Let's check. I mean, we have applied the right shift operation on this variable B. So the result was 25. So let's check the binary representation of 25 and see whether those binary representation has been moved 2 digits right or not. 25. Yes. So 11 1 0 0 1. This binary digits has moved two digits right by deleting 0 comma 0 and 0. You can able to see the length of this 1 2 3 4 5 6 7, and here the length was only 5. That means it has moved two digits right. The membership operators and the identity operators. So these are the two operators remaining. So let's get to know about these membership operators. There are two types of membership operators in Python. One is in and not in. Okay, membership operators test for the presence of a variable value in a sequence data types. For example, string, list, tuple, etc. So the membership operators in Python are in and not in. In and not in. So let's let's know what is in and how it is used. Let's know a simple example for this. A is equal to hello, B is equal to 25. List data type is equal to 42. So we need to check whether A in list data type. Of course, the value of a variable a was hello. We are checking that whether this variable, whether this value hello exists in this list data type. Hello, of course, and hence it was printed as true. Similar with, and also check with not in. A not in list data type. False, because we have the value of a exists in list data type, and hence the result should be true. But we also check that by using not in operator whether a not in list data type. No, of course a exists, and hence the result was false. And the last operator and the last operator section in Python was identity operators. So what are the identity operators exist in Python? They are is, comma, is not. So these are the two identity operators that exist in Python as a membership operators. So let's see each an example for this. Apart from that, what is identity operators? Identity operators are used to compare memory locations of two variables or two objects. As we know, everything is an object in Python. So let's declare two variables. A is equal to 10, B is equal to 9, and let's check with the first operator is. Let's check whether x is y, x is b. I'm sorry, it's b. X is b. We have created two variables x and b, and we are checking that whether the memory location of x is same as the memory location of b. Whether 9 is whether 10 is 9, it should be false. Of course 10 is not 9. And next go with is not operator. X is not b. Of course the value should be true because 10 is not 9. True. So this is all about identity operators. So we came to know about different operators in this tutorial, like identity operators, membership operators, logical operators, bitwise, assignment, comparison, arithmetic operators. So this is all about operators in Python. We have also learned one example with each one of them. I hope this helped with some of your learning process.